This video is going to look specifically at increasing and decreasing functions and the formulas associated with them. Okay, so first of all we have to investigate this function, so we need to write down what this function is. So we've got f double dot x becomes x cubed minus 4x squared. So the function is going to be f of x is equal to x cubed minus 4x squared. The question makes reference to a decreasing function, and the formula for a decreasing function is dy dx less than 0. And we have to find the values for where this cubic is decreasing. Now, we know a cubic equation looks something like this. And we know when we look at this picture that it is decreasing in this section here. Having a sketch about what's going on is, so we know it's decreasing between two values of x. Okay, now we know from the decreasing formula that we have to work out dy dx. So here we are now, f dashed x is going to be equal, multiplied by the power, put the power down 1, 3x squared, multiplied by the power, put the power down 1, and we've got 8x. We know from the formula that f dashed x dy dx has to be less than 0. So subbing in, we've now got 3x squared minus 8x is less than 0. This is a quadratic inequality, so we're now going to draw the positive quadratic. We did this this time last year on the course, and we need to draw in the x-axis, and we're looking specifically for where it's less than 0. So where this quadratic is less than 0 is here, and we now need the boundary points in order to solve the problem. So in order to find the boundary points, we are now going to be solving the quadratic equation. Now, it's really important that you remember in mathematics, you never divide an equation by x. You can divide equation by numbers, but never by x. You always factorize out. So the common factor is x, leaving us with 3x minus 8, and that's equal to 0. From this, using the method of zeros, we've got x is equal to 0, comma 3x minus 8 is equal to 0. So therefore 3x is equal to 8, dividing both sides by 3, x is equal to 8/3. So we've now got the two solutions. The smaller one is 0 and the larger one is 8/3. So where is our function decreasing? It's decreasing 0 is less than x is less than 8/3. So that fits in with our diagram over here. And so what we now know is that this is x equals 0, and this is x is equal to 8/3, this point here. And that's the end of that particular problem. Going on to the next one, it says find the range of values of x for which this function is increasing. So once again, it's a cubic equation. It's a positive cubic equation, which means if it's positive, it ends up going in the positive direction at the end. And we're looking for the range of values where this function is increasing. So this function is put in the local maximum and the local minimum. So this function is increasing here, and it's also increasing at this point. So there's two separate answers. So by sketching the graph, we already know that there's actually two separate answers. What else do we know? We know that the formula for an increasing function, is dy dx is always greater than 0. So we know that dy dx is always greater than 0. So what we have here is we've got f of x is equal to x cubed plus x squared minus x plus 1. So we're now going to differentiate this. F dashed x is equal to 3x squared plus 2x minus 1. We know from the formula that dy dx has to be greater than 0, so we know that f dashed x has to be greater than 0. Write that down here as well. And we know that f dashed is 3x squared plus 2x minus 1. So we fill it in, and now we have to solve this. We know this is a quadratic inequality. It's a positive quadratic. If it wasn't a positive quadratic, we would change all the signs. So we draw the sketch, and we're looking to solve it for greater than 0. So we're looking to solve it for this part here and this part here, which means it's going to get answers down here and down there. So in order to solve this, we are going to have to find the boundary points again. So the boundary points are going to be given by 3x squared plus 2x minus 1 is equal to 0. So first by last gives us minus 3. So we're going to have minus 1 by 3, and indeed that's the one that works. So we can continue. So 3x squared minus 1x plus 3x minus 1 is equal to 0. We're going to be factorizing in pairs. Common factor is x. We're left with 3x minus 1. We do the cheat. 3x minus 1 is equal to 0. Minus sign, is there a common factor for 3x minus 1? There isn't, so therefore it's going to be 1. Is my minus sign correct? Minus 1 on plus 3 is minus 3. No, so that needs to be a plus. Another check. Yes, 3x plus 1 and minus 1, it works, so we can continue. Always do the checks. 3x minus 1 on x plus 1 is equal to 0. So we've now got 3x is equal to 1, and we've got x is equal to minus 1. So we've now got x is equal to 1/3 and x is equal to minus 1. The smaller of the two is minus 1, so that one goes there, and that's equal to 1/3. So we've now got x is less than minus 1 and x is greater than 1/3 are the range of values of x for which this function is increasing. And that's the end of that particular problem. So here we've got the function f is defined on this thing here, and show that f is strictly a decreasing function on R without the value of 2. So what we have here is we've got f of x is equal to x over x minus 2. And the domain of definition, it's told us here, told us what the domain was. The domain of definition is the set of real numbers without the real number which is equal to 2. And the reason for this is because we're not allowed to have 0 on the bottom of a fraction, and if we've got x equal to 2, we end up with a 0, so we have to exclude it. We have to show that this is strictly decreasing, always decreasing. So we need to show that dy dx is always less than 0. It's always less than 0. So we need to differentiate. Now this is clearly the quotient rule. So f dashed x is equal to the bottom times the differential of the top minus the top times differential of the bottom all over the bottom to be squared. Now the bottom is equal to x minus 2 and the differential of the bottom is going to be equal to 1. The top is equal to x and the differential of the top is going to be equal to 1. We're now going to substitute it in. F dashed x, so we're looking at the bottom times the differential of top, and in a few moments time we're going to be looking at the top times the differential of the bottom. So just highlight that now. So the bottom is going to be x minus 2 times the differential of the top minus the top, which is x, times the differential of the bottom, which is 1. And we're going to divide that by the bottom to be squared, which is going to be x minus 2 all to be squared. I'm going to rewrite that formula and bring the numbers to the front. So it's 1 on x minus 2 minus 1 on x all over the bottom to be squared. And the bottom to be squared is going to be x minus 2 all squared. Okay, tidying it up, we've got f dashed x is going to be equal to x minus 2 minus x, and once again all over the bottom to be squared. So you've got x minus 2 to be squared. Tidying up for the last time, f dashed x is equal to minus 2 all over x minus 2 to be squared. And that is clearly less than 0, but you have to justify it. You can't just say that. If you don't justify it, you will lose marks. So why is that less than 0? Because the top is equal to minus 2, which is a negative, and the bottom is equal to x minus 2, and any real number squared is always positive, and a negative divided by a positive is always a negative. If you do not explain that, you will lose marks. Now, this next bit is turning points, which will be the subject of the next video.